Hello everyone and welcome to another stream by Black Hat Ethical Hacking live on Twitch. Today is Sunday the 17th of October 2021. Hopefully everyone is having a great weekend. So today we're with another Bug Bounty Sundays. As promised, this time we're going to be looking into Bugcrowd for Starlink. And we have developed a methodology inside here. So you can see that there is different IP ranges as well, which belong to Starlink, which is different than the ones that you can see from here. So this is important because the way you're going to be handling IP addresses, including the subnets, as you can see from here, this seems that there's a lot of machines that can be taken advantage of. So today we'll be focusing on this Starlink, which contains the star here, which means we can perform anything in the scope. So this is the GitHub where we can share the methodology and all of the tools that we're using. And we're going to start by creating folders. But before we do this, we're going to look into the methodology again. So last time you wanted to see more on MEG and how you can perform more using the techniques of choosing several vulnerabilities. So again, we show only Passive Recon. There's a lot of things that take place that we cannot show and share with you when it comes to the attacks. But you have to always prepare for a good recon whenever you're approaching a target and trying to tweak and automate a lot of things that you can see from here, writing your own scripts so you can focus on speed. So of course, when all of this is done, there's a lot of hours spent depending on what you're looking for. However, we cannot share this on Twitch, because we respect as well the program of Bugcrowd or HackerOne. We do release on Saturdays special episodes that can teach you a lot of techniques though that we can show and share with you. So we're going to start first by creating the folders on starlink.com. The way we're going to be approaching it is exactly the same as before. So the steps are, we're going to create the folders, we're going to use recon-ng in order to passively gather some subdomains. The way we configure recon-ng has different APIs, so we can get maximized results. And since it's passive, we're going to use probing. So we're going to use HTTPX in order to probe the URLs. We're going to check the IP addresses. And then we're going to move into using nmap, so we can import all of the results and the services, something that you should spend a lot of time if you want to work manually. So when it comes to bug bounty, if you use a lot of automation, and the tools that are out there without adding your touch and spending manually time on it, then you're going to have difficulty finding duplicates and you're going to find others. The easy ones are usually reported. So this is why you have to spend some time working manually. And as soon as we do this, we're going to use Sniper in order to perform mass web on the domains that we'll be getting. We're going to upload everything on the cloud and we're going to check for some OSINT stuff. So we're going to be looking at domain takeovers. And this is going to be done on using a tool. So we're going to use different machines to perform this as well. We're going to look for S3 buckets and then we're going to get some params passively using param spider. So today we're going to be spending more time. So as you can see, we're going to be also using smuggler to check for smuggling HTTP request attacks, which is very important for the next stages. So smuggler, you do see how it's used, but we cannot share how you can analyze whatever you find from here. So this is why you need to spend time practicing and trying to get to know how to work with different results that you're getting. So moving forward, we're going to get some screenshots as well using a VPS because it's going to consume a lot of bandwidth, and we're going to be examining the results as well. So when you examine the results, it's very important to look for specific things on the screenshots. And obviously all of this can, from the results, then you can start manually working on pattern checking. So using regex and your creativity, you're going to try to find some secrets and some codes and username passwords and APIs. So we're going to be spending a bit more time today on MEG and show you how you can perform fuzzing specifically for choosing what sort of things you're going to be getting out of the results of param spider. So usually we perform JS scanner. Last time we focused on JS scanner and how to read secrets from the results that you're getting from JavaScript files. And today we'll be focusing a bit more on Meg. And finally, we're going to be using XSS attacks. So as you can see from here, coming soon, we're going to be changing the way we use and attack cross-site injection with another tool called Dalfox. So hopefully next week we'll be introducing this and integrating it in our methodology to help you find and get more XSS injections when it comes to choosing the tools. So now we're going to start using this. So obviously at the next points, from all of the results and the passive recon that you do, you can then check using Nuclei, JLS and other tools in order to see if you can find easy vulnerabilities. But the most important part is to spend manual time examining the results and working on them. So at this point, we have just completed this and we're going to move to the next step, which is probing these subdomains. So in order to do this, we're going to first cat out the subdomains, which is under subdomains here. Then we're going to pipe the results into HTTPX. We're going to use verbose so we can check the status whenever it performs this, and we're going to create our URLs. So to do this, we're going to move to the results under URLs, and this is how you can basically convert the subdomains into URLs. So probing is one of the most important steps, and if you work on the targets or subdomains without performing probing, then you're going to have a lot of false positives and a lot of time spent without the need to. This is why we're going to cat the results from subdomains. We're going to pipe them as a one-liner into HTTPX, which is a tool that's going to probe them. We're going to use verbose in order to see that everything is working. And we're going to save the results into URLs, which eventually it's going to get all of the subdomains. It's going to use HTTP and probe port 80 and 443. So it's going to add the HTTP and HTTPS on them, which means when you start attacking at later stages, you know that the URLs are 100% there. So at this point, we're going to create the URLs, and this is going to run. It's going to cat out everything you can see from here. It's checking if it's being resolved, and those that are not being resolved are logged, as you can see from here. So this is done, and within seconds we have now the URLs. We're going to confirm how many URLs we've done. So these are the URLs, and the total number of URLs is 49. So this is why it's important, because instead of working on 200 subdomains, you're going to be working on 49 URLs, and the reason is a lot of these subdomains no longer exist. So when you perform active probing as following, then you know that 100% these links here belong to Starlink. So now that we have the URLs, we're going to move to the next step. You can see from here. So the next step is actually performing is up in order to confirm the IP addresses. So earlier we extracted some IP addresses. You can see from here. I'm going to go to IPs. So these are the IPs addresses. So if you look at the total of the IPs, we have a total of 58 IP addresses, but we really don't know if these IP addresses are responding. So in order to confirm this, we're going to use a tool which will probe them just as we did with the subdomains in order to see if they are valid or not. So the reason is always because when you run nmap against 58 IP addresses, so sometimes you can come up with 300 IPs, then you want to perform something that is valid, so you don't waste time when you perform your recon processes. So at this point, we're going to choose another tool. So all of these tools are on the repo that we have on GitHub. So this is the tool we're going to be using. And first, we're going to remove the old results. And now we're going to just run this tool. It's very easy to use. This is a script, and you're going to point to the location of the IPs that we extracted using recon-ng. So in order to do this, we're going to just point out to the directory. So this is the IPs, and the tool is gonna start. As you can see, the ones in greens are not responding, and those that are responding are valid. So this means it's gonna filter the results into two results. The first result will contain the ones that respond, and the other ones will be the not valid. This is how you have to work efficiently, and you have to be practicing on these techniques. You can even write your own bash script in order to automate certain things for you. So you can see now we had a total of 58 domains and only 40 were alive. So down were 18. So if I go to the results, I can see two results. I'm gonna copy the ones which is valid, because this is the one that we'll be working with. So we're gonna put it into IPs, and we can confirm now here. We have two results. We're gonna be working on the valid IPs. So these IP addresses do belong for Starlink, and we've performed only passive recon. We cannot perform any active or attacks on live stream because we do respect the program. So obviously there are various techniques in order to get even more IP addresses from these. So now that we have done this, we're going to move to the next step, and we're going to be running nmap on all of the IPs that we got. So this is the step, and we're using nmap with a custom command. So I'm going to copy the command, and I'm going to point it to the list of IPs that we just finished probing. So this is the IPs that we're going to be checking. This is the command of nmap. The way it works is nmap -il is for providing a list of IPs. So we're going to define the list that we just finished probing and sorting, which is under valid. And as you can see, the second parameters is to determine the service and the version that they're running. We're going to be using -a for aggressive mode and -t4 for speed. So we're using also -o in order to detect the operating system of each of the machines that they are running. -pn is also to bypass a lot of firewalls, a lot of evasion techniques, in case they have some sort of protection. -v is for verbose, -f is for fast, which means it's not going to check all of the ports, it's going to check the 1000 ports. We're going to save the results into Starlinks. So this is it. We're going to start running nmap. As you can see, it started getting us ports, and it started reading the IP addresses from the list we provided. So when this finishes, it's going to take a while, but we did add the -t4, which should perform faster scans. Then we're going to import everything into the cloud platform that you can see from here. So we're going to be going to the project data, and we're going to be importing, as soon as the results finish, all the data that we're going to be getting from nmap. It's scanning already 123 services on 40 hosts. And it is very important to start studying every single port and service when we import everything on the cloud. So we're going to move to the next step, because we're going to let nmap run. And we're going to be using... So sniper we cannot use now because we need to wait for nmap to finish, because sniper is going to be done on the IP addresses. Or actually we can run sniper on a different terminal since we already have the IPs. So we're going to launch sniper as well. So I'm going to get this command. I'm going to split the terminal. So we're going to open a new layout. So on here, we're going to use sniper. And we're going to just give it the list of IPs that we just finished having. And we're going to use the mode mass web. So mass web is dedicated for web apps. It's going to perform a lot of combination attacks, bypassing firewalls, checking with woof if it's using any protection, so you can perform a really good scan and try to get some vulnerabilities, CVEs, services that you need to spend time studying. So the Nmap scan is run locally, and we'll be using VPS shortly to perform another technique, which will be actually performing and taking screenshots of the URLs. So it's very important to choose how you're going to be running your machines, and what you'll be choosing to do is up to you depending on the hardware that you have. And it's very important to be splitting all of these into different machines so that you can not have any bandwidth congestion, especially if you're using Nuclei and other tools as well. So at this point, we're going to call the workspace Starlink, and we're going to let Sniper run. As you can see, it's going to start loading the IP addresses. It has created the workspace. So Sniper performs a lot of deep scans, and it's very important to look at the results when everything is done. So it's performing Nmap as well, port scanning. It's running HTTP probe. So it has a certain workflow that you need to be familiar with. You can use other tools as well, but we really prefer this because it's really valid, and we have automated things that can take place after this scan. So at this point, we're gonna let Sniper run. It's checking for vulnerability at this stage. We're checking on Nmap, and Nmap is gonna be continuing to work. And as you can see, Nmap has just finished. It took 379 seconds, and all of the results are here. But since you cannot understand the way they are displayed, we saved everything into an XML. So we're gonna move the XML file into the directory so we can import it on the cloud platform that you can see. So now that we moved it, we wanna import the results here. So import from tools, and we're gonna choose Nmap, the XML file that we did. So this is the XML file that contains all of the juicy information that we got from Nmap. So it's importing the results of 40 hosts, and within seconds, now you have an idea about the infrastructure of Starlink and what they're using. So this means that if I go to services and I expand this, I can start to understand that they're running 48 HTTP services. They're running some IMAP and POP3, some HTTPS and JetDirect, which indicates that they're running HP printers. This also means that some of the IP addresses are printers, and they're running a network server on them, which is available publicly. So you've heard a lot about how to hack printers and get access on them, and JetDirect is the specific service that does that. So what this means now is the most important part is to work manually on the results that you see from here. So by manually, this means you're gonna be spending time when you finish with your recon checking the POP3. So you can see it does say secureserver.net, but Dovecode is, if you're familiar with exploiting Dovecode services, I believe Metasploit has a lot of modules as well that can perform Dovecode and enumeration and other things. Then you're going to be looking into spending time looking at testing 16 POP3 services that are running. And the good thing about this is when you import everything, you can take a look in details about the certificates that they're using. If you find something that has been expired, as you can see, there's a lot of things to study and work here. So this is the services, which shows you the infrastructure of Starlink after the Nmap scan that we saved into XML. So besides services, you can look at the products, and products also shows you what they're using. So we already know they're using Apache. So recently there's new Apache CVEs that have been running with their own POC. So this is where you're going to be spending time testing all of the Apache servers that you have from here. So manual work is what is very important for you to do in order to go beyond just the automated scans and find something manually in order to get a bounty that wouldn't get you any duplicates. So at this point, we were talking about Meg and using the results. So we need to look into sed again. So I'm going to use sed on this. And essentially what we want is we want to remove the word fuzz so we can keep it empty. So as I was saying, you can use SQL map in order to check for SQL injection. Another really good tool is to use JSQL. This is the tool here, which will also test for several techniques for attacking and trying to find SQL injections or other types of injections when you provided a link with parameters. So make sure to configure it, because the way to configure it is very crucial. And you can provide any link from here and just add it here, and it's going to perform automatically some injection attacks for you. But now we're going to be using Meg in order to perform this manually. So first I'm going to just give it a sed, and then I'm going to give it. So this is the combination. I'm going to add sed here, and essentially I'm going to replace the word fuzz with an empty character. So to do this, all you got to do is, you can see now it has removed the word fuzz and it's ready. So we're going to save it. And we're going to call it meg results.txt. So if I cat out these, you can see now that this is ready to be used with Meg. So the secret of using Meg is not just about the tool, it's understanding what you're looking for so you can perform a specific attack. So this is the command of Meg, and I'm going to break it down. So before we run Meg, we also need to take a look at the dictionaries and payloads. So we'll be needing one more tab here. We'll be just using the bottom tab. So we're going to go to fuzzing, and we're using sec lists. So sec lists, we talked about it, it contains a lot of payloads, and intelligently and smartly you need to understand what to choose from here so you can attack. So for example, we want to perform fuzzing. If you go to fuzzing, you can see that there are different types of payloads. For example, SQL injection. This means that if you look at the results here, it means that you have results of URLs, right? And what you want to do is you want to inject after the parameters that you can see from here. So parameters is whatever you see before the equal sign. So a website usually hides its own parameters so that hackers don't easily get access to URLs that contain parameters, so that they don't have to inject anything into it. When you talk about injections, there's thousands of things you can do. When it comes to injecting, you can inject code, arbitrary code, LFIs, and different patterns. So this is why when you come here and you look at the payloads, you have to understand first each one separately. If you don't know what SQL injection is, then first you have to spend time understanding what SQL injection is. When you reach that stage and you're clear with it, then you can perform Meg in order to choose the dictionaries and payloads that already exist for you here for SQL injection. If you're working on polyglots, then you have to study about polyglots. If you want to work on injecting for like databases, then you have to understand about how to use databases, because this is what you'll be doing manually. So if you're looking for XSS, this is another way as well to use Meg to perform XSS injection on these URLs after each of the parameters and examine the results. So the reason you use Meg, unlike Burp Suite Pro, which focuses on Java and a lot of resources, is speed. If you use tools like wfuzz or Meg, or FFUF, then you are taking advantage of the power of the terminal and working faster as a bug bounty hunter. So we're going to take a look as well at the eyewitness in order to check quickly the screenshots. So in order to do this, I'm going to curl out the results of the IP. So we're going to share the directory using updog, root, and running on port 1337. So this should be it. And this is the results of the screenshots that we took. It's saved under a folder. And you can take a look at, there's 2 pages of the report. We can use view in browser in order to examine the results. So you can see that immediately you can take a look at the screenshots and you can see that forbidden is different the way you approach it. And you see from here immediately that there is a sign-in page. So a lot of times we found some SQL injection errors or some content just on the main page, and this is why it's important to take a look at these. So this is a webmail. So this is why taking a screenshot of each URL is important, because imagine you have 10,000 URLs and you want to take a look at them visually. So one of them is here. You can see that this is a very sensitive thing. So this is very interesting because you can see that it says troubleshooting details. We cannot share the results. So this is why taking screenshots is important, because this error could indicate that it's very interesting to look on it closely. And you can see that there is a lot of information here that you can study in order to move and get an idea about the URLs that you're working with. So stay tuned as well. We're really glad to see you again today. And as always, until next time.